Right, guys, we spoke about negative exponents yesterday, just briefly. I just wanted to reinforce what we spoke about in terms of negative exponents. Suppose you had an expression x to the power 3 divided by x to the power 5. Okay, what you want to do in this case is um, from grade 8, we learned that we take the power with the lower exponent and we shift it towards the power with the bigger exponent. Okay, we know already here that we're gonna apply law 2. Dividing the powers of the same base, you subtract the exponents. Okay, so I want to look at two ways here, just to emphasize the negative exponents, just so to explain. And as you'll see, negative exponents exist, but there's a way to write it in such a way that it is a positive exponent. But it's not incorrect to have a negative exponent. It is absolutely correct. Will be so. I'll show you that today. I'll show you that today and how we get to the negative exponent. Okay. So firstly, I just want to solve this problem by in expanded form. So if I expand the numerator, I'll have x times x times x because it's 3x. In the bottom, I'll have x times x times x times x times x. Okay, 5x's. Okay, and then I will cancel like terms there because I've got the divide in between. Okay, so on top there, I will be left with 1 because all the x's on top have disappeared, and I would left in the denominator x times x, which is x squared. Okay, so we know that's the answer. We've worked it out fairly simply. So let's see now. Option 2 in this scenario is what we learned from grade 8. It's about basically taking that power and shifting it down to the denominator. When you do that, the sign is going to change. So let's look at this option here. Let's go option 1. So what we're going to do is we will have 1. Remember, there's still 1 here in the numerator, so that's fine. So that 1 remains there. We will have x to the power 5 minus 3. Why? Because we've taken that power to the denominator. It becomes that. Okay, that will mean 5 minus 3 is 2. So we'll have 1 over x squared. Okay, notice something, that we've got the same answers because we're applying rules here. We're applying exponential rules. We're not doing anything out of the ordinary. So now I want to look at option 2. Let's say option 2, we ignored what we learned in grade 8 and we said, now right now we're going to shift that to the numerator. Yeah, shifting that denominator, that power in the denominator to the numerator, the same rules will apply. The exponent must change its sign. So we have x to the power 3. We will multiply that. Okay, I'm just going an extra step here, minus 5, just to show you. In the denominator, we still have 1. Of course, when we have 1, we don't have to do anything with the 1. We can leave the 1 there. Okay, so we've just shifted that power to the numerator. So now we can apply law 2 here, multiplying powers of the same base. We add the exponent. So we'll have x to the power 3 minus 5, which is x to the minus 2. Voila. Let's see. Now we have a negative exponent. Okay. So what I'm showing you, so that must be the same as that. The same as that. Okay. So those three answers must be the same. So what does it mean then? Does negative exponent mean if you have 1 over x squared, it is the same as x to the minus 2? Notice that this is the same as just applying law 2. You just, when you shift a power to the numerator or the denominator from either of those, the exponent changes its sign. Okay, so in general terms then, what are we saying? In general terms, we're saying if x is to the power n, it would be the same as 1 over x to the minus n. Okay, or if we have 1 over x to the minus n, we will have x to the n. Basically, that's the general rule. We're going to look at examples in the next video.